So far we've made histograms of the quality ratings of natural peanut butter and histograms of regular peanut butter. And so in this lesson for problem 1.2, we're actually going to do part 2 of question B. We're going to make another histogram using the quality ratings of regular peanut butter, but we're going to change the interval size to 15. So we're going to make really big intervals. And this is going to be for our regular peanut butter again. So same idea. So we went from 5 and now we're going to actually expand it to 15. So I'm going to again look at my data here, my list, and the regular peanut butter start right here and go down to the end of the chart. So these are the quality ratings that I want right here. That's my column of quality ratings. And again, the intervals now are going to be 15. So if you think of this first interval, 0, and then the next interval starts at 15, and then 30, and 45, 60, 75, and 90. So those are my cutoff points for each interval. And so you might already be guessing that, with bigger intervals, it's going to change how this whole graph looks. So if I start with my first one, that's 76. So 76 would go in this interval, 75 to 89, and then 60, and this one, 60 to 74, and 54 in the 45 to 59 interval, and 43, the 30 to 45, and 40, and this one, 30 to 45. So again, I'm just choosing the numbers off the list, working my way down the list, and keeping track. It's a nice thing about a histogram, it's pretty easy to make. 35 goes in here, 30 to 45, 34 in the same interval, 33 in the same interval, 31, same interval, 2 23s, they're in the 15 to 30 interval. And I'm just checking them off the list as I go. The 11, way over here all by itself, in the 0 to 15 interval. 2 83s, so 75 to 89 interval. 54, there, 45 to 59, 49 in the same interval, 45 to 59, 46 in the same interval, 45 to 59, 40, which will now go back in the 30 to 45 interval, 34, same interval, 31, same interval, 29 in the 15 to 30 interval, and the last one at 26, again in that same interval. And so I've used all the numbers, and now I have again a regular peanut butter quality ratings. Histogram. These are histograms. Kind of like a bar graph, but again, I'm just keeping track. I could, like this, my count on the side if I'm thinking of count. So now my bars of my histogram. And remember, I didn't list the numbers, I just kept track, and my count 1, 2, 3, 4, 5, 6, 7, 8, 9. And so again, if you look at the distribution of the data, really doesn't change in terms of this direction. Our range still is 0 to 90 approximately. We do have this one interval that kind of pushes out this direction a little bit because we have such a big grouping here. But really what happens, if you notice, is the height changes. So it gets much taller. We have a range of 9 from the smallest to the highest. And in our previous graph, in the intervals of 5, it was our smallest. We only had a range in this direction of 5. And then in the original graph we did for quality ratings of natural peanut butter, you see that the height of this one is 7 with an interval of 10. So with the interval of 10 was 7, interval of 5 is 5, interval of 15 is 9. So you see the greater the intervals, the larger the intervals, usually the height, or the greater the frequency variation. So we have a higher frequency. We have all the way from 9 to 1, whereas in this one we have from 5 to 1, and this one 7 to 1. So the number of intervals. Now the question here is how many bars do we get? 1, 2, 3, 4, 5, 6. So we only got 6 bars. So we have fewer bars, but we have a greater frequency. And again, the rule of thumb on histograms is you want to choose intervals that will give you between 8 to 10 bars. And so in many cases this one is, the intervals are too big. 15 is too great of an interval. 5 is in some ways too small because here we had 11 bars. For the case of the quality rating of natural peanut butter, 1, 2, 3, 4, 5, 6 bars really isn't enough. So we probably would want to use a smaller interval for the natural peanut butters in order to spread this data out. If we have a large cluster here from 60 to 69, maybe if we did intervals of 5 or 7 or something like that, that would spread that out and we would see a little bit more clearly where the data falls in that range. But all of these histograms still give you some important information. This one tells you that the quality ratings for natural peanut butter are in the 60 to 70 range, mostly, typical. And both of these, even though they look different, still tell you that if you look at the quality ratings for regular peanut butters, there's kind of a cluster of data all right here in this zone with a bigger chunk in the 30 area. And the same thing in this one. If you look at this, the 30 to 44 is what we would call typical or most common, or where the ratings for regular peanut butter mostly fall. And you compare that to the original graph done, the original histogram was done for you. Remember with this one, we look at this, it's in the 30 to 50 range, which would be most common. And so that again matches up with, we said 30 to 44 in here is fairly typical. You can see there's a few more that will probably fall into that 50 range. And even with this one, if you said 30 to 50, you can see that again that's all within the data clustering range. This is what we call a cluster of data. And so the data clusters in this area, and so that's what we consider to be typical. And really we use this for comparison purposes because now we could look at the quality ratings of natural peanut butter and compare it to the quality ratings of regular peanut butter and see that the quality ratings of natural peanut butter in general is higher than regular peanut butters. And so that's one of the purposes and useful these kinds of graphs and this kind of data. So that just gives you an overview of things that you'll be using in problem 1.2. There's some other questions that follow, but this is the important part, being able to take the data and actually turn it into a histogram and be able to make these charts. So hopefully that's helpful for you as you do problem 1.2 in samples and populations.